Hello and welcome to everybody, to the people in the room that made it tonight despite the weather, and to the ones that are tuning in online. This is my first time introducing an ORF event, so I'd like to introduce myself. My name is Paolo Cherubini. I am a postdoctoral research associate at Heriot-Watt University here in Orkney. I moved here about 3 years ago, and I joined the ORF board of director last June. So I came here to Orkney to work in our research group that works on transition engineering, but my interest in particular was on the nexus between fuel poverty and grid infrastructure and the energy system. So I had during this time the opportunity and the pleasure of working a bit with Martin, who has been so kind to um, give us some of his time and expertise doing while we were doing our research. Martin has spent 14 years working in Orkney for the Scottish Hydro, and then more working. He has done more work for SSE down south in Inverness and Reading. So he has a absolutely extensive knowledge of the power system, specifically the Orkney power system, but power and energy systems in general. So his presentation today is going to be about, I think, the past, present, and future of power and energy systems in Orkney, in the UK, and possibly beyond. Which I think it should be there will be a space for discussion at the end of his presentation, which I would expect that there will be many questions, since it's always a sensitive and topical subject, the fact of energy and price in this time of geopolitical turmoil, and as we with the issue of resilience towards extreme weather events and all of that. So I think that energy is always something that is um, will surely be of interest. So without further ado, I'll leave the floor to Martin. And I'll see you
Okay,
later.
thanks, Paulo. Okay, so keeping the lights on in Orkney. It's not actually a simple thing to do. Some people might look at it from one point and think that's quite simple. But we've got lots of things to think about. There's the practice, what the guys on the ground do. There's a policy. This is a national policy that says what we can do. We've got practicability. We're not the same as in a city where if you have a substation go down, you can feed power from the next door substation. If you live in Westray, you can't feed it from Edy or Rousey. It's just not possible. Tables aren't there. The price, we've got to think how much money is spent on the job. And then I'm finally going to look at prospects. What's the future? What may we expect in Orkney? We'll start off with practice. So the most basic level, as you as a householder, you keep your lights on when there's a power cut by things. I've got candles, torches, tilly lamps, and you decide that. Nothing to do with national policy or anything like that. At my house, I've got an automatic emergency lights, like you see in pubs and restaurants, so that when the light power goes off, both my stairs and another part of my house, which has got a ramp, are lit. So there you can not get caught out halfway down the stairs and trip over or anything. And we've got half a dozen small torches and left in places that are easy to get at. So I'm relatively well prepared. I never experienced a power cut until after I retired. When my children were small, we used to have to play power cuts because we never got any real ones because Dad was always away fixing them if there was one on the go. So what I've got at home, I think it's a good start. And I'm going to avoid having an accident in the dark. That's the most important thing. So this is just for general information, but not everybody knows yet. Part 2 of the plan, phone 105. It's a common number for the whole of GB. And if you phone that number, you will get put through automatically to what they think is the local distribution network operator. And if you're in Orkney, they're going to get it right. So part 3 of my plan is to get out the candles. I've got boxes and boxes of candles. They're absolutely old-fashioned. But I was brought up in 1973 during the miners' strike when we had rota power cuts, off for 4 hours out of every 12 quite often. So candles are still a valid option if you've got adequate ventilation, but not all homes do. So well-sealed homes probably shouldn't be using candles. Battery-operated lanterns are better. And if you've got a home battery, which some people do nowadays, then you can rig that up to run an emergency lighting system. So part 4 of the plan is just to sit and wait for the DNO to come and fix it. So the boys, I'll call it the hydro because that's what I was most of the time I was working here. The boys from the hydro will come out, they'll find the broken wire, repair it, or the blown up transformer, replace it, whatever's happening. And hopefully that's all I'll need. But it may not be. What if the power cut goes on for a long time? So a fifth part of my personal plan, keep warm. I've got extra duvets, jumpers, woolly hats, can keep warm in the house. Keep fed, emergency food stores. This is a government recommendation that everybody keeps at least 3 days of emergency food now. And keep informed. So an FM radio which can operate on batteries and spare batteries. Radio Orkney will be able to broadcast updates. Radio Orkney have about 6 different slots throughout the day that they're allowed to come in and go over the National Radio Scotland programmes. They very rarely use them, but that facility is there. So they'll be able to tell you what's happening. So we're going from practice to policy. Now, a lot of people speak about an N-1. N-1 just means that if you've got 5 generators, you can take one away and the 4 will provide the power that you need. You can have N-2 or N-3, you know, N- any number you want if you've got enough money to waste. We don't use it very often in the distribution business, but it can make sense for a power station. And I'll talk about that later when we get to Kirkwall. So in reality, you might have to maintain generators. So you need more than the generators that you're actually using to provide the load, so that you can have one that you're doing a repair to, or you can allow for one breaking down. And we could apply the same principle to the whole electricity system, but we don't. Hands up who's got 2 electricity supplies to the house. Nobody. So you've got 2.
Well, have a sort now, yes, but
You've not got 2 coming from the main supply, no. And very few people do. Some businesses do. It's just too expensive. We don't do it. We don't duplicate everything. Your supply to your home is not N-1. Very few supplies are installed using N-1 formula. Those that do are usually things like data centers at banks and things like that. And they might have N-2, N-3 for their supplies, because they might have 2 mains power supplies, plus standby generators, plus quite often they've got batteries that'll run them while they get the standby generators up and so on. So this is just a little sketch, and I'm going to. This is a typical substation. A ring main unit at 11,000 volts, a set of fuses or a circuit breaker, a transformer, and then a low voltage bus bar with circuits feeding out, and your house is fed off one of the circuits. And we've put a green line around it. 1 megawatt or less. Typically, there is no alternative supplies. Anything of that lot that goes wrong, you're going to have to wait till it's repaired to get the power back on. Or if it's going to be a long time doing the repair, they might bring in mobile generators to get you plugged up, get the power back on for you. So while we accept that for up to 1 megawatt, if we did it for the whole of the electricity system that we had no backup. Say we got the one cable to Orkney that was there for many years, failed, and we had to wait till that was repaired, and it took 3 months or 4 months to repair. You can't afford to have folks in Orkney with no power for 3 or 4 months. So there's a graduated system set out under a document called P28, Security of Supply, and it says how long the DNO have to be able to repair or to ensure that the power doesn't go off even after the fault and so on. And I'm going to go through those things now. Class A, up to 1 megawatt. That means there's no backup at all. It's down to repair time. Class B, 1 to 12 megawatts. All but 1 megawatt must be restored within 3 hours. So if you think about it, you look at the Orkney, it's got a demand of over 30 megawatts. It doesn't count for Class B, it's too big. But if you look at a smaller area, like Stromness, it's going to fall into that 1 to 12 megawatts. And for that area, you've got to comply with that. You've got to all but 1 megawatts restored within 3 hours. And the way it's done is you start with 2 circuit breakers at the substation, multiple substations, each one of which could be up to 1 megawatt. And you have what's called a normal open point. And a normal open point is just a switch which is open. If we get a fault on one of these circuit breakers, so the faults occurred at this substation, this circuit breaker would trip, all these folks would go off, and you'd lose more than 1 megawatt. And what happens is we go out, we've got 3 hours to do this in, we work out where the fault is, and we open switches here and here to isolate that fault. And then we close that normal open point that was there. So there was the normal open point closed. We've now got all these on, and we've got 1 megawatt up to 1 megawatt off, and that 1 megawatt is down to repair time, just as it was right from the start when we talked about the first thing. So when we get above 12 megawatts, we go to Class C. So 12 to 60 megawatts within 15 minutes rather than 3 hours. The smaller of the expected group maximum demand minus 12 megawatts, or 2/3 of the maximum demand, has got to be restored within 15 minutes. So 15 minutes is too quick to rely on guys getting in their cars, driving out and looking in substations and operating switches. It's got to be done automatically or remotely, and sometimes it's one or the other, sometimes it's both together. So this might be a system that we have where we're looking at 12 to 60 megawatts. It's represented by 2 primary substations, one here and one here. And then the 11 kV feeders, they're interconnected and they've got open points. So all these open points are there, and each circuit is fed from one circuit breaker back at a primary substation. If we get a fault that affects one of the transformers at a substation, then say it's this one, this transformer can supply all that load and go to all the open points. And if need be, if the load can't be sustained long term by this one transformer, we can move these open points from here to a different location. Sometimes we get faults that affect more than just the transformer. So in this case, if one of these faults occurred, these 2 feeders would go dead, and we would have to move open points to get supplies restored. And we have to get those supplies restored to 2/3 or 12 megawatts less than the total demand within 15 minutes. But we've got 3 hours to do the rest. And that 3 hours means people going out and closing these circuit breakers. And this is just a graph showing how much you've got to do within 15 minutes and how much within 3 hours. And then we go up class B, 60 megawatts to 300 megawatts. Now you might think that's outside the range of Orkney. And I'm going to talk later on about it, but I don't think it is. I think that we potentially could easily get into that range of above 60 megawatts. For a single fault, only 60 megawatts, only 20 megawatts can experience a supply interruption of greater than 1 minute. And the load loss must be restored within 3 hours. So once we get above 60 megawatts, there's no repair time. That anybody has to wait for repair time. You can lose only 20 megawatts, and you've got to get it back on within 3 hours. And this class starts to move beyond N1, N-1, in that it allows for a second circuit outage. So all the other ones we've talked about, if we had one fault, we would meet the standard because we got so many people back on. If we got a second fault, everything could be off if you're up to 60 megawatts of load. Second circuit outages, they mean that if you've got a line out already and you get a fault, you can still maintain some supplies. If it's up to 100 megawatts, there's no requirement to maintain supplies, but then 100 to 150 megawatts, you can lose only 100 megawatts. And then above 150 megawatts, it's 2/3. 1/3 of the demand must not be interrupted. So I've got a little graph here for it. So we've got the line where for a single circuit fault, everything must be restored in 3 hours. We've got the line where for a single circuit fault, we've got to keep everybody on except 20 megawatts. And then we've got this second circuit fault line here. And we don't have to get that back until 3 hours after the fault. So we could lose everybody for a second circuit fault and then get what was on the green line back. So it's still going to see an interruption. Oh, right. Doesn't apply to a second fault. So this second circuit outage does not apply if you've got two faults at the same time. And then just for sort of completion, we're not going to get here. Class E, first circuit out above 300 megawatts to 1500 megawatts. First circuit outage, no loss of supply exceeding 1 minute. Second circuit outage, no loss of supply to 2/3 of the potential maximum demand. Customers off supply until the first outage can be restored. That's what the rules say. And Class E, which is even bigger again, this is specifically written for every single grid supply point by the transmission companies. It's nothing to do with distribution. Sorry, I'm getting mixed up here. Oh no, that's Class F, above 1500 megawatts. Basically, it means no loss of supply for both a first circuit outage and a second circuit outage. And National Grid typically have substations with 4 circuits feeding into each substation. So you can have one out and you can have a fault on another one and you've still got 2 left. National Grid in England and Wales have circuits which run round in rings, and we tend not to have that in the more remote parts of Scotland, though Hydroelectric at the moment are seeking to do that for the Dounreay circuit. They're looking to build another 400 kV line from Caithness down to Bewley, so that circuit that goes up through Bewley, from Bewley up to Dounreay and back down to Bewley again, will have 4 circuits. They'll be the same as it is in England and Wales and Central Belt of Scotland, actually. So practicability, what does it mean? The first thing to note is no loss of supply doesn't mean you won't notice a fault. faults cause high amounts of current to flow, which blow fuses or break protection. That reduces the voltage. So when you see a fault, your lights dip. And you can sometimes see it in Orkney. You'll see your light dip for a moment and then come back again. And that dip in the lights is caused by fault current on another circuit usually. If the circuit that has got the fault on is your circuit, your power will go right off. Again, it depends on the fault. 120 milliseconds for transmission circuit faults, 400 kV. So it's a very, very quick interruption, or dip in the lights rather. But it can be several seconds for some faults on the distribution network. So restoration can come in two forms. Clearing a fault will allow the voltage to restore to normal, or by switching in alternative supplies. So that's when your power's gone right off and then you switch in alternatives. And those alternatives can take different amounts of times. If they're automatic, it can be done in 10 or 20 seconds. If it's less than 1 minute to switch in alternative supplies, it doesn't count as a supply interruption. It's different to the standard for reporting a supply interruption though. So the standard for reporting a supply interruption that the DNO has to say that customer's had 3 interruptions is that it's got to be up for 3 minutes for each time to record a supply interruption. It used to be 1 minute, but it's changed. Class B group demands of 12 megawatts. Switched alternative supplies are the common method of meeting this standards. Often you meet the standard in less than 3 hours, and they're often available for demands of under 1 megawatt just because of how easy it is to build the system in particular times. All the North Isles primary substations can be switched to alternative supplies, even though the loads on these substations are under 1 megawatt. So if you lose a supply to a substation, you can switch it round to another one, and you're better than the standard basically. Demand is measured by customers taking electricity. Generation doesn't count. So we have some primary substations in Orkney where we've changed the transformers from 1 MVA to 4 MVA, but because the demand on those substations is under 1 megawatt, they still count as demands of less than 1 megawatt. Should the load exceed 1 megawatts on these substations, then consideration is to be made to the cost of meeting the standard. Often small increases above 1 megawatt are allowed as the cost of a second transformer is high and the incidence of faults on transformers is low. So a substation exceeds 1 megawatt by far. The greater risk, if a substation load exceeds 1 megawatt, by far the greater risk is of a fault on the outgoing 11 kV circuit. This can often be split into smaller parts to allow faults on the 11 kV circuit to be compliant with the standard. So if you remember, for 1 to 12 megawatts, you've only got to get the power back by switching around, and you can leave up to 1 megawatt off. So Rousey, Edy, Stronsey and Shappensey have networks which split into more than one part very close to the substation. And that's how they meet the standard, even if the load was to go above 1 megawatt. Westray and Sandy have 2 circuits feeding from the substation, so that for 11 kV circuit faults, only one loses supply and the other remains connected. And Westray and Sandy are the ones that have got the biggest loads in Orkney. Westray feeds Papa Westray as well, and Sandy feeds North Ronaldsay as well. So on the mainland, circuits with loads above 1 megawatt are all backfeedable from adjacent 11 kV networks, as described in the Class B thing that I went through. Flotter and Hoy probably have a total load under 1 megawatt. If not, it won't be much above. And the cost of doing anything is too expensive to justify. But finally, Bury and South Ronaldsay. The load there has been above 1 megawatt for 30 years. The cost of doing anything has in the past always been too high to justify. That's no longer the case. SSEN are currently working to provide a compliant solution with a new substation to be located in South Ronaldsay, with 2 cables connected to it. When completed, around 2028-29, it would result in Bury and South Ronaldsay fully compliant with P28. Given the geographical challenges of many islands to supply, Orkney's network has been reasonably compliant with the standard. However, we haven't looked at the next group of upwards, larger scales. Kirkwall and Stromness meet the requirements for Class C, though only Kirkwall has loads above 12 megawatts, which push it into this class. The final group demand I'm going to look at is the sort of critical one, which is Orkney as a whole. And I'm going to look back at how security of supply developed for the whole of Orkney. So this is a bit of history, and this is where Jim's got to keep his mouth shut if I made any slight mistakes. Starting shortly before 1982, Orkney was supplied from Kirkwall Power Station and a 3 megawatt gas turbine on floater. So we'd got 8 generating sets in Kirkwall, which could produce 25 megawatts, short-term rating of 27.5. The maximum load was 18.6 megawatts, and generation was covered by an N-2 scenario where 8 megawatts represented the 2 largest generators could be out of service. So 25 minus 8 at Kirkwall plus 3 at Flotter gave 20, which is above the load of 18.6. So it met the requirements. It was okay. Might not have been easy, and I'm sure Jim would stand up and tell you the few hairy times when generators were running fairly heavily loaded because other ones were out of service and so on, but it was done. And most of the time 3 or more generators could be off. So there was time to switch generators out to do maintenance and repairs and so on. So 82, Orkney got its first 33 kV interconnector cable from Thurso, rated at 20 megawatts. And Kirkwall Power Station got a 9th generator at 6.5 megawatts. These 2 things allowed for potential loads of up to 34 megawatts, assuming that the largest circuit outage was the cable. And we always take the largest. If you've got 2 options, you take the largest out. And no allowance was to be made for generators not being available. Generators would be pushed to the limit at peak load if they were required to operate following a cable fault. From 82 onwards, the Orkney load grew very quickly, and the peak load grew even faster. How that was managed is a separate talk I've written here. There's actually a paper on the ORF website saying how that was managed. So you don't need a separate talk. You can just go and look up the paper on the Orkney ORF website. By 94-95, the peak load had risen to 32 megawatts. So from 18.6 in 1982 to 94, gone up to 32 megawatts. That's more than 50% extra in 12 years, quite a bit. This was close to matching Kirkwall Power Station's rating, and there was no longer a gas supply to the gas turbine in Flotter. A decision was made to install a second 33 kV cable. This was installed in 1998 and had a slightly increased rating of 22 megawatts. Shortly afterwards, Kirkwall Power Station was reduced to 4 generators with a capacity of 15 megawatts. So in 1998, we reached the current situation. So there's not really been any significant change since 1998, with cables rated at 20 megawatts, 22 megawatts, and a power station rated at 15 megawatts. If we go back to P2/8 and look at the load of around 32 megawatts, then Orkney falls into Group C, 12 to 60 megawatts. And following the first fault, we need to restore at least group demand minus 12 megawatts, or 2/3 of the group demand within 15 minutes, and group demand within 3 hours. There's a graph showing that. You can, if you wanted to, you could use this graph to see where 32 megawatts was here, and see 32 megawatts is about there. You've got to get 20 back within 15 minutes, and the whole 32 within 3 hours. So what happens? How does Orkney keep it going when one of the 33 kV circuits trips? Because if you've not running the power station at the time, and all the embedded generation is off, there's no wind turbines running, you get one tripping, the other one's going to overload. And what happens is there's a scheme in place that detects the overload, sends some signals to Kirkwall, and very quickly trips off circuits in Kirkwall, just enough to bring the load down to less than 21 megawatts. So that scheme has been in place since 1998 or 99 it went in, I can't remember exactly. And that's what keeps the lights on for the vast majority of people. The fact that we sacrifice supplies to a certain number of people, and then we've got to get guys in to the power station, run it up, and once they're generating enough power, we can get all the other supplies back on. Having said that, a lot of the time, 21 megawatts is less than the actual load. So we might not finish up shedding anybody if the load's under 21 megawatts in the first place. So this scheme in place just marginally fails to meet the standard if the load's over 31 megawatts. But again, it's one of those things, if it just marginally fails to meet the requirement, you can look at the cost and say it's going to cost £1 million or £10 million or whatever, and it's only a small failure, and that small failure is also for a very short period of time. So you take a risk-based approach and you don't do anything. But above 35 megawatts, the standard cannot be met. So when I was managing the demand in Orkney by switching teleswitch times, so that the total control and the white meter and all the other ones that were available were switched at various times to keep the load below 35 megawatts. That was my priority. I used to be in the power station Monday to Friday every morning. What happened last night? Did what change? Did the previous day's change make it worse or make it better? And then to keep it below 35 megawatts. I don't have any data beyond 1999. I did have data after that, but it was lost in a data accident later on, when somebody wiped all the data off with being accessed for 6 months, which is unfortunate. And I only recovered the stuff before 1999 because I'd had a student party from a university that have a link to Stromness. Came in and I did a talk and I produced a paper with all the data on, and I kept a copy of the paper. That's the only reason I've got the data at all. So the management of the load was very, very significant. It allowed hydroelectric to save deferment for many, many years. This grey line here, that's an estimate of how the load would have risen if all this increase in load in the orange line was just down to extra people having extra storage heaters. Now, that might not have been what really happened. It's just an indication of how the peak load was going up much faster than the total load. But some things didn't change. As more people switched to storage heating, the peak load was going up, and the overall load was going up much less. The blue line is what the actual peak load was, and this is 1995 here, 94, 95, and you see a sharp decline. and then it started following the line of increasing total load, but lower. And that was down to me spending hours every week, basically, faffing around and trying to keep the load down. So I was trying to keep it below this figure here, 35,000 kilowatt hour. Yeah, so 35 megawatts. And if you look at that orange line, if I hadn't done that and the blue line had kept up, we would have been over in 98, 99. We would have been out of compliance with the standard. So the new circuit only improved Orkney supply security as measured by P28 from 34 to 35 megawatts. A huge amount. The main reason wasn't to improve the supply security, it was to cut down on the amount of running that was being done at Kirkwall Power Station. And I think the last year we had the peak lop on about 200 days out of 365, so more than half the year we were peak lopping, which is quite significant. So if we're following the installation of a new 220 kV circuit to Finstown, is everybody aware that we're getting a new 220 kV circuit to Finstown? Anybody that's a surprise to? Nope. Right. So there's two options. Kirkwall Power Station could be removed. Then following a fault on the circuit, most of Orkney will lose supply and we'll be able to restore supplies using the two remaining cables rated at 20 and 22 megawatts. The capacity can rise, secured capacity can rise to 42 megawatts from 35. And I believe that this would be inappropriate. So this is my personal belief. It's not a policy that I've heard anybody in SSCN say. I think it would be wrong to shut the power station. Two reasons, but the first one is load management advantage of teleswitching has been removed. Summer 2026, it will have disappeared altogether. So all the teleswitch controls that I spent all that time working on to keep that load down below 35 megawatts, they're all being replaced with smart meters. And the people that run the smart meters don't have the same incentive that I did to keep the load down. I can't really find out what's happening. I've asked various people and nobody knows, because Hydroelectric was a vertically integrated company. You could pick up the phone and find out about anything in 1995. You could speak to the people that set the price for electricity. You could speak to the people that sent the bills out. You could do all that. Now it's all split up into so many different companies. You can't find out. And even if you find somebody who does know a bit about it, they don't know how it fits in with the rest. So we've got a situation where nobody's got one big overriding view of the electricity industry. In theory, Ofgem do, but I don't think they actually are successfully managing it. Anyway, and white meters, like my white meter, was set for a different time than the published 11:30 to 7:30 cheap rate, but it's actually been turned back to 11:30 to 7:30 a.m. And that, I mean, removing the variations in start time means that lots of meters are going to be switching on at roughly the same time. There's actually a small delay of up to maybe 5 minutes. And that 5-minute delay doesn't stop you getting a big peak round about any particular time that once arrives. And then the second reason is there's lots of new loads coming onto the system. We've got some new large loads for electrification of ferries, like the shore supplies for Hamnavoe. There's potential for shore supplies for 3 new North Isles ferries, which when I went along to the consultation events, the battery pack capacity could be 12 megawatt hours per boat. So if you look at that and say they're not going to use it all every day, but maybe 8 megawatt hours out of 12 megawatt hours, they're going to need a 1 megawatt supply each night to recharge the batteries, each boat. So that's 3 megawatts. There's new houses going up. We're still building lots of new houses. All new houses have to have electric heating. That's the only way they can meet the standards now. They can add in things like PV. PV doesn't meet, the PV is not contributing during the time of peak demands. In winter evenings between 4 and 7 is typically the peak demand on most electricity networks. It's different in Orkney, but that's another story. And as we have more houses, we need more water, so we have more pumping. And there's then the switching of heating systems from oil and coal to heat pumps. So the government are giving grants to people to switch. And if you've got a oil-fired boiler, you can probably change to a heat pump, and you'll get 3/4 of the cost paid for by the government. So there's lots of incentives to increase load. And EVs, which I love EVs, but that's another one. So I've put in the short term, keeping Kirkwall Power Station operational will allow the 42 megawatts on the 2 cables to be augmented by 15 megawatts in terms of calculating the available secure supplies under P28. So it gives us 57 megawatts, a lot more than 42. It's a significant load, which we could argue, and we can talk about it in the discussion, whether we're going to get there. It works out to more than two-thirds of 57 megawatts can be restored within 15 minutes, 38 megawatts, by using the 2 cables, and the remainder within 3 hours using Kirkwall Power Station. The real question we need to ask is 57 megawatts a realistic, never to be exceeded maximum demand? I've already shown you a graph, though, that showed how loads could have exceeded 57 megawatts by 1999. That this was avoided was due to load management by hydroelectric, recognising that small losses due to providing power at slightly more expensive times was cheaper than the huge reinforcement costs to meet the load. So this was hydroelectric, an integrated company who could take the balance and say, we're going to supply cheap rate electricity at an expensive time to customers in Orkney. It'll cost us £500,000 a year, and that's going to save us £50 million on a reinforcement. So all of a sudden they say, we're not going to spend the £50 million on reinforcement. We'll spend the £500,000 on supplying cheap rate electricity to customers at a loss, basically. The thing is, as privatisation took place, the businesses from the mid-1990s onwards, it all got dismantled. I actually talked about this a moment ago. I didn't move the slides on fast enough. And these things that were done to save money in reinforcement costs in places like Orkney and Shetland, the Western Isles, Mull, nearly every island that you look at, you can find that something was done to avoid reinforcements. And these were worth it to the North of Scotland Hydroelectric Board, or the Hydro, but not worth it to the suppliers now. So the electricity suppliers now, so we've inherited this tariff, and this tariff is producing customers who are taking power at what was a cheap rate at a time when the electricity supply is more expensive. And that is the reason that people are paying more for their electricity in Orkney. They're they're not paying more for the electricity. They're paying more for their heating because they're using a tariff which is using electricity at a more expensive time. And that's actually been detrimental to people in rural Scotland, and specifically in islands. And I've put there, the north of Scotland and especially islands have borne the cost of this. And it's important, though, to say that some of this is recognised, and SSE ends operations in the north of Scotland are supported by a scheme called The assistance for areas with high electricity distribution costs. And if you see the acronym AAHEDC, that's what it means. This means that every customer in the whole of Great Britain, so that's the whole of the UK except Northern Ireland basically, pays a very small amount per kilowatt hour extra into a fund, which is then reimbursed to Scottish Hydroelectric to subsidise the cost of running the distribution networks. This financial year, £81.7 million was used to subsidise SSEN's costs in running the distribution network. That's not including Shetland. There's a separate fund which paid £33.5 million to Shetland to run the power station in Lerwick. So that's a substantial amount of money. And roughly, that's £100 per customer for people that live in Orkney. And it's about £2,000 per customer for folks that live in Shetland. Where the system doesn't recognise the issues are where customers on tariffs, which by design use electricity at times of day when prices are higher. Total heating, total control, which was widely used to manage the load in Orkney. An economy 10 tariff, which is used to replace total heating with total control when smart meters are brought in. Use electricity for about 3 hours per day at the cheapest times. The rest is used when prices are mid-range, so they don't push it into the most expensive times of the day, but they do push it into mid-range. It's not the cheap range that it used to be when we had white meter, which was overnight. Ofgem are encouraging suppliers to provide real-time use of tariffs, time of use tariffs, and if taken up widely in Orkney, which I think they will be, then Orkney's peak load will shoot up. So if at the moment you're on a tariff where you get 3 hours cheap at night, relatively cheap at night, 3 hours relatively cheap in the afternoon, and 3 hours relatively cheap in the evening, and you then find out that you could actually operate your system by taking 8 hours of electricity overnight at a much lower rate, you'll jump. But when you do that, what we'll find is that the overnight load in Orkney will shoot up. And that's why I think that when I've said around here post-third circuit, I mean the first 220 kV circuit, the security limit of 57 megawatts will be exceeded. The solution is to install a second 220 kV circuit to the substation at Finstown to meet the supply security standard P28. Basically, this would then put us back in the same situation as the rest of the country. We would be equal to what happens in Caithness, or what happens in East Grinstead, or whatever bit of London you fancy naming. It moves the group demand over 60 megawatts into Class D, and I've put or does it, because actually, with 2 circuits to Finstown, you could supply 60 megawatts from Finstown, and the 2 older circuits can supply up to 20 megawatts. They're fed from different grid supply points. The 220 kVs coming from Dounreay and the 33 kV from Thurso South don't really make a lot of difference. So that's that slide. So I'm really sort of getting to the point where I'm going to summarise. P28 gives guidance on how to provide secure supplies in a consistent manner across the GB electricity networks, and that's important. This standard, while it's not a hard and fast rule, is used by Ofgem to make sure that DNOs don't spend too much money and sort of gold plate their schemes. And it's also used to as a bit of a stick to DNOs, that if the customers are complaining that they're getting a lot of interruptions and they don't meet this standard, then Ofgem will use it as a stick and say, you'd better spend some money on that, you're not meeting P28. It might not always be practicable, and with submarine cables often taking months to repair, we need to consider what is needed to keep the lights on in Orkney. Given 2x2 20 kV circuits and two 33 kV circuits, we can see that there is a chance that both two 20 kV circuits are out of service at the same time. And a question I've put is, how do SSEN propose to deal with this? Currently, if more than one fault occurs, the plan is to bring in mobile generation. There's two switchboards at Kirkwall Power Station where we can connect up to 20 megawatts of mobile generation, half to the north side of the power station and half to the south. There's no time limit on this, so if they had to bring in 20 megawatts of mobile generation, they might be able to find 5 megawatts based in Inverness and 5 megawatts based in Glasgow, and the other 10 megawatts at one time, when we asked where it was going to come from, it was going to come from Rotterdam and would take 72 hours to get to Orkney when I did an exercise back in the 90s. I don't know what the situation is now. But they would have to do it, and they would have to get people back on. There was an instance back in the early 2000s, I think, when there was a major fire at a substation in the northeast, and they had to bring in a 60 megawatts of mobile generation to get the supplies back on. So that's the sort of thing that can be done. With two potential limits on the capacity regarded by P28 as secure after the installation of a first 220 kV interconnector Finstown, that's 42 or 57 megawatts, one without the power station and one with, and the limit is the first circuit outage. It's got to be restored within 3 hours. And if we put two 220 kV cables, 220 kV circuits in, the limits are 142 and 160.5, and those limits are not first circuit outages, they're second circuit outage limits, which have to be restored within 3 hours. But even if you go to that situation, it means only 42 or 57 megawatts will actually be reconnected within 3 hours. The rest of the load will be off until the planned outage can be completed, if it is a planned outage. Oops. Most important thing about a second 220 kV circuit is that there will be no interruption following a first circuit outage. Second circuit outages are rare, and maintenance can often be arranged to take place when actual loads are low enough to avoid long-term interruptions. Class E, which is above what we actually are interested in, but I've included it because it's quite interesting that it says group demands over 300 megawatts specifically state that second outages should be managed so that maintenance is carried out when loads are low enough to allow a second circuit outage without loss of supply. So even though the standard is 2/3 of group demand have got to stay on, if you manage it so that your first outage is when the load is less than 2/3 of group demand, you can get a fault and no lose any supplies. I would argue that right now we could easily expect Orkney's group demand to exceed 57 megawatts within a fairly short time, and I expect that it will already be above 42 megawatts by the time the new interconnector comes into service. What I'm saying is that the changes that are occurring now are already pushing Orkney outside of P28's limit of 35 megawatts that we have. I think we're already out of that, and that should be encouraging SSEN to carry some reinforcement works out, and indeed they are, because they're going to take 50 megawatts of capacity from the new substation to the distribution network. So they're actively doing what they should do, the things being done correctly. But I think we need to pursue a case for a second 220 kV interconnector to Orkney. It'll take a long time. It won't be a 5-minute job, but we ought to be arguing for it. And current NESO plans, or National Energy System Operator, they took over part of what used to be National Grid, that managed the grid system, and they were bought out by the government and given a new name last year or the year before. 24 it was, so it's the year before now. Their plans up to 2040 do not show this extra interconnector, even though it will be vital to allow Orkney to take its place in the renewable heavy grid. What arguments do we need to make? And here's the Orkney. This is in the beginning of 26, so just a month ago. No extra circuit to Orkney. And just if in case anybody from Shetland's in, there's a little note there. Shetland is not missing from this map. You can see the cable to Shetland. That's a point to it there. And there's a little white blob there that's Fair Isle. It's just if I zoomed out to include Shetland, you could hardly see anything else. So what happens as we move along? We get the first circuit. This is in beginning of 2030. And you can see the Orkney circuit. And you can see there's a second circuit to Shetland by then. But then if you move forward to 2040, Shetland gets a third circuit and we're getting nothing extra. And I think we need to be making an argument for that. So, final slide. Discussion. We've got to weigh the balance. Do we want to make sure that we use lights, electric light bulbs on the my right hand side? Yeah, it's on your right side as well. Or are we going to rely on candles? So I'm going to open it to the floor. Would you like to chair this? Then I can put my arguments in if need be. Thanks, Paolo.
Yes.
Thanks for that presentation. Yeah, on you saying there's no sign of any other connector, I've had some correspondence through MSP, etc., with I think it must have come from Ofgem, suggesting that there is some plan to have some extra interconnectors from Caithness through to South Ron. You not know anything about that? Just on the drawing board, but nothing firm yet.
Well, it's not a transmission connection according to NISO.
Okay.
Yeah.
Yeah, and one other question. Just trying to understand how the whole system is put together. We've got this new interconnector coming through, but my understanding is that's largely about two cables, basically. One to send power from Orkney to the mainland and one to bring us as a spur connection off the grid. Not that?
No.
But if that cable is broken, can we redistribute within Orkney power that is generated within Orkney, or are we just out of action?
Right. Well, at the moment, when you say two cables, physically, there'll be two cables. No, it's an AC circuit. There's one big cable with 3 wires in it. There'll be 3 wires in one big cable. If it fails, that goes all together. That same cable can bring power from Dounreay, where it's connected on the mainland, to Orkney, just as easily as it can send power from Orkney back to Dounreay. It's rated at 220 kV. It's probably, though this is a guess because SSEN won't confirm it, got a rating of about 250 MVA, which is not megawatts, and it's probably about good for about 220 megawatts. And that 220 megawatts and 220 kVA gets lots of folks confused. I get confused myself. But that's roughly what it will be able to provide. You cannot say for sure that it will be able to provide the same amount of power in either direction. The existing circuits that we've got will provide 42 megawatts into Orkney as real power, but the MVA rating is higher than 42 combined. But in export terms, because of voltage control limits, we can only export 34 megawatts at the moment. But we don't ever get to 34 megawatts. I've looked and I've never seen anything higher than 26 megawatts being exported from Orkney. That's because a lot of the generation in Orkney is under the A&M scheme. And while we could have had more generators connected, people weren't willing to take the chance that they wouldn't be cut off by the A&M scheme if something happened. So we're not fully utilising our existing export capacity.
But if Russia severs all the connectors, can we redistribute? Sorry, if Russia, for example, severed all our interconnectors, primarily to stop power getting sent
Right.
to the mainland. Can we redistribute what we generate within Orkney or not?
Well, yeah. What at the moment, the generation that we've got in Orkney, and it does provide supplies to Orkney first. We only export once we've supplied all of Orkney. So, if the load in Orkney, I'll just pick some round numbers, 20 megawatts, that's the load in Orkney. If the wind turbines in Orkney are producing 15 megawatts, that whole 15 megawatts is used for Orkney customers,
Okay.
and we bring 5 from across the cable. If it gets windier and the output from the wind turbines rises to 25 megawatts, 20 megawatts of that 25 supplies the customers in Orkney, and we export 5 megawatts back to Caithness across the cable. Now, we've actually got over 50 megawatts of wind turbines in Orkney at the moment, but the most that I've ever seen exported, I can't remember exactly the numbers, to be honest. It's under 30 anyway, and the circuits could export 34 megawatts. So we never fully utilise the export capacity of the circuits that we already have.
Something.
But when we get this 220 megawatt capacity or 220 kVA on this new cable, we'll never fully utilise it. We will have the capacity to connect another 220 megawatts of wind turbines, but they will never ever all be producing all full output at the same time and sending it all across the Pentland Firth. Because we always use what we use first. We only export excess. It's. Am I making myself clear, or do you want?
Yeah. From the answers I got back
mean,
from SSCN and Ofgem, I don't think they understand that either.
If you want, I'll speak to you after the talk, and let somebody else have another
Evelyn online.
answer the question.
Was that Evelyn? Sorry.
Yeah.
Okay, I'm just going to go and ask a question. I think what was being asked and kind of relates to my question is if both of the cables were not working, would the renewable generation in Orkney supply the demand in Orkney? And I think at the moment the answer is no, it wouldn't, because everything or most things would be intertripped, so they would be turned off. So my question is, what would need to change from a policy or technical perspective to allow renewable generation to provide some of the supply for demand during fault conditions?
Right.
Did you get?
Yes, I understood what she said. Yeah. So what Evelyn's saying is at the moment when there's a fault on one of the cables, the commercial arrangements say that some generators have to be stopped from operating. So there are generators which can connect anyway, and those would allow, following a cable fault, they would be allowed to stay on. But following a cable fault, some of them would be taken off, and they could potentially supply electricity to Orkney that would be useful, but the contractual arrangements currently take them off. And that requires a considerable amount of flexibility on behalf of SSEN and all the generators. And my practical experience is that SSEN stopped being flexible because some of the generators were not willing to be flexible. I can't say any more than that. Is that enough, Evelyn?
Thanks, yeah.
For those that don't know, Evelyn is my daughter, by the way.
Any other questions from the room? I do have a question, Mark, because
Yeah.
it was really fascinating, especially in when you did the history, no, of supply. It seems like there was a transition between a centrally planned system, like with a vertically integrated utility, that was that had a whole system view of costs, no?
Yeah.
When you were saying about like that they had a very clear idea that modulating the demand, as you did now with the white meters, avoiding coincidental peaks, would then lead to savings by avoiding reinforcement. And then this thing seems to have been lost, no? After with the reform and with the private. Is that what is missing here?
Well, it was a decision that was made by the regulator, Ofgem, that their view was that across the whole of GB, it would increase competition, and the government at the time, in the sort of mid 1990s, were wanting to encourage competition, and so Ofgem started the process. I can't remember exactly when it started, but sometime in the 1990s they started dismantling the vertical integration, and it got to the point by about 2010 that they were actively going after people who were still retaining some of that vertical integration and saying, stop, don't do that. So just a very simple example. When you go to put a new supply in, vertical integration allowed you to put the meter in at the same time as you put in the supply. And the guy that put in the supply would take maybe 1 extra hour to put the meter in. So the cost of putting that meter in was 1 hour's labour. Then when Ofgem stopped that, you got a situation whereby if you were doing a new supply in Glasgow, you put in 10 new supplies and left it, and a different firm came along and put in 10 new meters. Now, the guy that put those 10 new meters in took 10 hours to put them in, just the same as the guy that did before, and he would increase his costs by half an hour for his travelling time. So that wasn't much, and the regulator said this is worth doing if you look at that situation, totally ignoring the fact that if you do it in Orkney and you put in a new supply in Papa Westray, that the guy that puts the supply in Papa Westray spent several hours, maybe even tens of hours in travelling time, getting there to do the job and getting back home. And then you send in somebody from based in Inverness at best, and quite often Glasgow or even Leeds, you're sending them to Papa Westray to do a 1 hour's job to put a meter in. And it was just bonkers. But the regulator insisted on it because he wanted to have a common set of rules across the whole of the country. And that to me was wrong. There was no proper assessment of what the cost of that common rule was. That's why I said Islanders lost out. And you would have seen the thing in the paper a few years ago where people were complaining they were having new supplies put in and they couldn't get the meters put in. Mm-hmm. And that's the reason they couldn't get the meters put in, was that the meter operators were saying, I'm not going to go to Orkney to put in a meter that's going to cost me £900 in travelling expenses and £45 for the guy's wages to put the meter in. Mm-hmm. You know, and that lack of vertical integration has hit, and it's hit hardest in the islands, and it hits harder in the smaller islands. SSEN are already being subsidised by millions of pounds from that long complicated acronym that I can't remember without looking it on the screen. They're already being subsidised by that. And why, when they're being subsidised by that, do you then penalise the customers by saying you can't have that vertical integration bit? So there are sensible things on vertical integration that could be done that would make things a lot better. Mm-hmm. And I've argued about it. I've written to MP, MSP, Ofgem, and I've written to Ofgem and they've said, well, no, we think we're right. We think you're wrong. You know, that's the best you can get. The MP and the MSP write to Ofgem and they write back, no, this is policy. There's a good reason for the policy. But I still think they're wrong. But I'm a one person that can see what the benefits of vertical integration were.
Okay.
And I could probably find you 3 or 4 other examples, but metering's the one that's the most obviously wrong, and the one that was most in the press a few years ago.
Neil, yeah. Neil, go ahead.
Hi there. Martin, thanks for that tonight. That's been really good. Having been involved in renewables for 20 years, I've learned a lot tonight. So thank you for that. That's really helpful. One bit that I was bumping my gums about and got absolutely nowhere, so I'm equally frustrated but slightly less sanguine than you are, was about this issue of the fact that the substation that's been constructed at Finstown, they very sensibly have taken enough space to prepare the site for 2 circuits. So they're building for 1 circuit, but actually there are plans available to do a second circuit if the need rises. But I just can't understand why they've not put 2 sets of ducts in across Orkney when going to all the hassle of laying the ducts all the way to Warburth. They've also put 2 bores in at Warburth, which I'm not quite sure why. Certainly, I was heard that one was a spare, which seems quite an expensive spare. But I just wonder if you had any comments about the fact that would there have been any advantage in putting a second set of ducts in the trench or another trench in the same easement when they've gone all the way across the county, or would it be better from an electrical engineering point of view to take a completely different route for a second circuit from Finstown?
Right. Well, I agree with you. A second set of ducts would have been useful. They took a 50-metre wide strip of land. They stripped a huge amount of topsoil. They built a road. They built a trench, and they put the ducts in. You can't put the ducts too close together. You've got to keep them a reasonable amount apart, and that's to do with getting rid of the heat from the cables. It takes a while to propagate through the soil to the time it gets to the surface, and then it disappears into the air. But you probably could get away with ducts spaced at about twice the depth, maybe 3 times the depth might be better. And it would have been very, very simple to have put the road down the middle of the strip that you've dug for, you've taken the topsoil off, dug a trench down one side, put the ducts in, reinstate that trench, dig a trench the other side of your road, put in the soil on the opposite side of the road, put a second set of ducts in, do the whole thing. You only ever strip the topsoil once, you've only ever got to do the reinstatement once, and you could have had 2 sets of ducts in there that would have been perfectly adequate. The spacing would be more than enough to provide security against somebody accidentally digging them both up at the same time. Because I can assure you that if somebody digs one of these up, they'll know about it. And before they've got round another 4 meters or whatever you've spaced them out, you'll have found out before they dig up the second one, So just a small aside, just for a small laugh possibly. I once had a guy phone me up, a contractor in Orkney. I think it was on a Tuesday, and he says, "Oh, I'm very sorry, Martin. My guy that has been carting silage in this particular farm, he's run the silage cart still tipped up, and he's run into an overhead line and fetched it down." So I said, fair enough. We went out there, fixed it, all job sorted out. Thursday, the same guy's on the phone saying exactly the same thing in exactly the same place. And I says, what, did the guy not learn? He says, no, it's not the same guy. I sacked him. This is the replacement guy that did it. So he'd sacked one guy for doing it and never reminded his replacement guy not to watch out for that line. Anyway.
Right. Just a quick comment when you were talking about the the lack of vertical integration in the metering for the domestic supply side. We've had a few cases over the winter and over the last 3 winters now, actually, where folk have gone off supply due to prepayment meter fault. And despite there being engineers in the county clearly replacing the radio teleswitch meters that you talked about earlier, the ability to deflect that, to get them called out for emergencies has been really difficult to the extent where for a couple of cases we had to put tenants up in alternative accommodation because they were failing to meet the timescales to get them back on supply. And this culminated just the other week where we had 2 folk off supply on the same night. One of the just coincided to be one of the really wintry nights that we had, on the ground and all. And I plugged away to over the supplier till about 9 o'clock at night until they reacted. Because I had walked my dog past an Airbnb where the smart meter engineer was actually staying, and I met him, and I told him that there was a couple of houses off supply, and he had returned to Sandy, but he was in Kitwell all night, and they hadn't called him out to. It seemed logical to me that there was time to call him out to replace these 2 meters that were faulty. So it spoke volumes to me that, despite, having some engineers on the island, would just not have the capacity to, get them diverted onto these emergency call-outs the way they would have been done in your day. So that's one. That's another way that we're losing out on that.
Well, could I just stop you a second, Robert? The thing is, that's just another example of a lack of vertical integration.
Yeah.
But it might well be that the guy couldn't go and sort your problem out without failing his prearranged jobs, because he might not have had the stock of spare meters. Now,
Yeah.
at the time that we had a vertically integrated system, there was a stock of spare meters kept at the store next to the power station, and you would have had anything from a dozen to 30 spare meters available that you could have taken out. So you could have dealt with many jobs. But these guys have got five prearranged jobs, and they bring five meters with them.
Yeah.
They don't carry the stock of spares. But you're right. It's exactly a lack of that vertical integration that is causing that. And to make it worse, you'll find that different companies have different meter operators.
Yeah.
So you might find that one failure is a Scottish Power meter operator, and he's not in the island, but the Eon meter operator is. But the Eon haven't got an agreement with Scottish Power to cross their meters.
Yeah. Yeah.
When smart meters came in, not smart meters, when remote reading meters first came in, which were for 3-phase supplies for commercial premises, Scottish Power got a contract to do all of the supermarkets belonging to, I think it was Presto at the time. And then Presto had a shop in Kirkwall, but Scottish Power didn't want to come up. But they had the common sense to phone up and say to the meter operator man in Aberdeen for hydroelectric, can we subcontract putting these meters into you? And he said yes. So I finished up putting the metering in at Presto's with a system that I'd never seen before, or never seen again, and a small instruction leaflet. And we put the meters in, tested them, got them working, and it all worked. But that has been actively discouraged by the regulator Ofgem.
Yeah.
Yeah. It's not the electricity companies themselves that have driven this particularly. It's Ofgem saying we want competition. We believe that by splitting things up, we will get better competition. And it might well be the case that is true in big cities or even in relatively large towns where it's not far from town to town.
Yeah.
In rural areas of Scotland, islands, and small islands especially, it is absolutely horrendous.
Yeah.
You know, all the North Isles of Orkney, most of them only have one SSE representative. And at one time, they would sort your meter out.
Mhm. Could I just make a quick point too on the radio teleswitch changes, you know, the post RTS tariffs? And you were talking about, I think maybe you're worried that the charging times possibly would be longer, or there would be more demand anyway. There's less need for the companies to be managing the peaks and flows of that. Is that a real fear if more and more storage heating is installed and more electric heating is installed in Orkney at the moment?
Well, it's not about whether more's installed. I mean, more being installed would potentially be a problem.
Mm-hmm.
The problem isn't more being installed, but the existing storage heaters, of which there are, you know, there's thousands of houses with storage heaters in Orkney.
Mm-hmm.
At the moment, they're split among various groups that were teleswitch groups
Mm-hmm.
to make sure that they weren't all on at the same time.
Mhm.
So take, for example, the old white meter. A lot of those were split into two groups, and some were on from 10 till midnight and then switched off for 2 hours.
Mhm.
And the second group was on from midnight till 2 and then switched off for 2 hours. And then they came on at 4 o'clock. So you finished up with 6 hours where only half of the storage heaters were switched on.
Mhm.
At 4 o'clock, by the time they were all switched on, you'd already reduced the load because storage heaters don't take the same amount all through the night. They take a high amount of power, they're equivalent to the rated power, for a number of hours, 1, 2, 3 hours, depending on how much heat they need. And then they start cycling. They switch on and off. But the net effect over multiple storage heaters is for the load to go along and then to start to drop off like that.
Mhm.
And eventually, it'll go flat. And when it goes flat, it looks like just a quarter of what the rating is.
Mhm.
So by doing that, we move the peak from midnight till 4 o'clock or whatever. We also reduced that peak considerably. By 4 o'clock, the peak wasn't as high as it would have been if they'd all switched on at midnight.
Yeah.
And as I said, there is a paper on the OREC website that I wrote that explains all this. I mean, it's another whole lecture, to be quite honest.
Yeah. Yeah. I mean, we're seeing higher costs, and we spoke to Jim last week about this. The shift between the tariffs, and they've done a dive into that over the winter, and they were reluctantly admitting that the prices are moving up the way more than they would have been comfortable with in their first look at that. So, you know, that's a concern that we're seeing. And the rate 2 usage in one property that I was looking at the other week, well, when they had the RTS meter, that was about a 60-30 split on the rate 2, and 20% of that is now shifted onto rate 1 just through, well, mismanaged installations of meters, I would guess, and that's taking time to rectify too. So the tariff prices are going up, but then normally installed meters taking time to be rectified. It's costing customers when they were told there was to be no disbenefit to them financially. So
Well, as I said, that's something I mentioned. That what will happen is they will say, why don't you take that customer and put all the storage heaters on for the 8 cheapest hours in the day? And they will probably do that, and you might be quite happy about it, but it will increase the peak load
Yeah.
that is experienced by the system, and it will produce a situation that Orkney becomes less secure in its electricity supplies, and that will cause Ofgem to say we have to do something, and that will need more circuits. So whether it's another 220 kV circuit, which I think is the sensible reason, the reason I think it's the sensible solution is that there is enough capacity applied to more than fill the existing one in terms of export capacity. And we have a very good tidal regime within Orkney, so north of the mainland, which cannot be supplied by connecting to substations in Caithness. It's got to be connected into Orkney for tidal energy. And tidal energy, I would hope that before 2040 that tidal energy is substantially more than it is now. The cost per kilowatt hour might not be as low as wind, but there's a particular benefit of tidal energy is when it's going to be. It's going to be there all the time. If you've got the right time tables, you could tell what power is going to come from a tidal energy site on the 1st of January 2040, just as much as you could tell what's going to come from a wind turbine in 5 minutes' time. So there's extra value for that knowledge, that constancy of output, and I think that we certainly should be doing that. So this gentleman here suggested there was the potential for connections to Caithness, not through the Finstown substation. That might be. I've heard rumours that there might be something going on, but there's no firm plan being published. Nothing's being consulted upon. So as far as I'm concerned, it's something they thought about but haven't decided to do. And I think it would be wrong to decide to do it because it would not be the most cost-effective solution. The best solution is the 220 kV circuit to Finstown because it's given us all that extra export capacity as well as securing our electricity supply.
Okay. That's another question then.
My understanding of the 220 volt cable that's going in now, it was justified purely on the grounds of exporting power. In fact, agreements had to be in place for a certain amount of generating capacity for it to happen at all. And we were not told that it was that it was about resilience or future developments of distributed power. It was all about exporting generated capacity, and that was the justification.
Yeah,
I really,
that's quite
under
right.
the current environment,
Yeah,
I just don't see how we're going to get a second cable.
well, I'm telling you now tonight something I realised about the security of supply last year, and when I realised it, I spent some time thinking about it, and I asked Neil, think about November. Neil, would it have been? Would I give a talk? Because I thought it needed bringing out, and people needed to start to understand that it does provide increased security supply. You're quite right; it was justified on generation connections, and they're principally going to be paying. They're going to be paying the significant amount of the cost. The difference between the generation connection is the generator pays the cost of the extra work. If it's a distribution connection for load, the customer pays, and if that pushes hydroelectric's costs even higher, then all the customers in the UK will pay because that ADH or whatever that acronym is will have to increase to subsidise Scottish Hydroelectric. So I think that a 220 kV cable will provide the extra security we need. It will also provide double the export capacity of a single cable, and there is plenty of justification to have that extra export capacity. The one thing I've already mentioned is the tidal energy that is available within Orkney from principally between Rousey and Westray, and I believe that there's potential for a couple of 100 megawatts in there. So that alone would take up an extra cable. There also is an advantage in wind power being distributed at more remote locations from the central loads. Which, if you think of the central load as being London, and you've got wind farms out in the Thames estuary. Thames estuary could be dead calm because there's a low pressure area over that. When there's a low pressure area over the Thames estuary and the wind turbines are doing nothing, we'll have high winds in Orkney and Shetland and the Western Isles. So the further away you get, the more the advantage. And I call that geographical diversity. And geographical diversity has a value. And certainly Shetland and the Western Isles, especially, more so than Orkney and Caithness. But Orkney and Caithness still have a good geographical diversity advantage over building more wind farms in the Thames estuary, for example. You wouldn't want to build all your wind farms in the Thames estuary because you'd lose all the power at the same time if there was low pressure there. But if we lose power here because we've got low pressure, what gets generated in the Thames estuary can be exported from the Thames estuary right the way up to here. We could be running on power from there on days when we've no wind power. And
I'm convinced, Martin, that I'm not sure the people who have control over commissioning these works are listening.
Well, that is my
Sorry
point.
to be pessimistic.
That's why I said I've not put questions. I've put discussion. We need to discuss it, and I mean this is Orkney Renewable Energy Forum. One of our aims is to promote renewable energy, and that is something that I'm particularly keen about that we do. Prior to 1992, I didn't think wind turbines were anything but beautiful machines that looked lovely when they were spinning around, and not necessarily all the ones at Burger Hill. But basically, in 1992, I saw what happened at the Rio Earth Summit, and I read the information. You couldn't find it online in those days. You had to find a particular magazine that had a report on it. But I realised in 1992 that climate change was real. We had to tackle it, and that renewable energy was the solution. And since 1992, I've been pushing for more renewable energy.
I'm a believer.
Yeah.
But how on earth can we convince? I mean, there's other things that are happening, like batteries, huge batteries becoming cheaper and cheaper. The possibility of being able to rely more and more on renewable energy is there, and it's growing.
Well, yeah.
Even in Trump's America.
Well, yeah. Or in parts of Trump's America. But yes, cheaper batteries will make renewable energy more flexible, but it's not the only answer, because if you look at PV output, it's about 6 times more in summer than it is in winter in the UK. It can be slightly even more in Orkney, but typically it's about 6 times. If you go to Southern California, it's twice. And if you go to a place near the equator, there isn't much variation between. They don't really have they don't have a summer and winter. They have a rainy season and a dry season, but the daylight is pretty much the same all the year round. So if you're close to the equator, PV is ideal. If you're as far north as we are, and you had to store energy from the summer to the middle of winter in battery, it just would not be anything like economic. So we're far better off having a mix that's predominantly related to what the weather's like in terms of wind. So wind fits better for us because we get more wind power in winter than we do in summer, and we have more load in winter because we're using it for electric heating, and that's going to increase. We're going to find that we finish up with more electric heating as people put in heat pumps to replace gas and oil boilers. That in itself will increase efficiency because heat pumps are much more efficient than gas and oil
I know.
boilers.
I use.
Yeah. So there's a whole raft of things that pushes towards saying we need wind power, and we need it in areas that are away from the big loads. So Orkney and Caithness are pretty good. Shetland and the Western Isles are even better. And we need to develop it, and we need that capacity for that. But I'm looking at it from a different point of view because the argument for capacity for renewable generation has been sat there for years, and we've discussed it. And it's only last year that I realised actually there's a good argument for doing it this way in terms of supply security, which is what my talk really has been trying to bring out. Anybody else, anyway?
There is a Evelyn again online. Wanted to.
Yeah. So there's quite a lot that I want to comment on, to be honest, but I think just sticking with sort of Stuart's last point there, and actually what you were just saying there as well, Martin, that there is a need for additional sort of onshore wind and renewables as generally in places that are away from where the demand is. Was it last year or the year before, NISO were commissioned by the UK government to produce the Clean Power 2030 plan. And within that, in theory, they have considered geographic diversity, but only to the extent of this is the north of Scotland, this is the south of Scotland, and then a number of regions within that. And from that study, they decided that there was a certain amount of onshore wind, solar, and battery required in each of these geographically locations that are actually quite large. Now, just summer, and actually we're still seeing the outcome of this. There was a change to the way that projects are able to connect to the network, and it's been sort of dubbed connections reform. And as part of that, everybody that was currently in the queue needed to be reassessed. So this has been called the gate 2 to whole queue process. And so the outcome of that so far, and we still need to know the full outcome, but the outcome of that is that all of the battery, onshore wind, and solar capacity that NISO said was needed by 2035 has already been assigned effectively. So we're still waiting for those offers to be reissued to the generators, and then waiting to find out who's going to accept those and who's not going to accept those. So we're in a bit of a weird situation where if you want to connect generation before 2035 in the north of Scotland, your project needs to be less than 50 kilowatts or 200 kilowatts, because that's what the transmission impact assessment threshold is. That means you have to go through this new process. I've probably not explained that fully well, but just in terms of things that we can be doing to try and change this is Community Energy Scotland are asking for that transmission impact assessment threshold to be increased across Scotland. So for each area within Scotland at sort of grid supply point level, so Orkney would be one area, to reassess what that level would be so that it could potentially be higher than 50 kilowatt. So that's what we've been asking for to help unlock some sort of smaller scale renewable generation. And something I read just today actually is that Ofgem are going to ask the DNOs to reassess the G98 limits. So that basically means that, sorry, 2 seconds. That basically means if your generation project is less than 3.68 kilowatts per phase at the moment, you can connect it and then inform the DNO. But Ofgem are saying that they're actually wanting the DNOs to reassess to see whether you could actually increase that limit. again, to make it easier for people to be installing renewable generation at smaller scale. So there's no question in there, really. Myself and Martin have discussed some of the issues with Clean Power 2030 plan before, but yeah, I just wanted to provide that information and see if anyone had any thoughts on it. I know it's pretty negative.
I'll see you next time I see you.
Fair.
Thank you so much. Well, in that case, Neil, yeah, you want to come in again?
If there's somebody in the room who's got the mic who wants to jump first, I've already had a go. But I suppose the point I would make is, as a forum, I think we need to use our voice to try and get some of this stuff changed, because I don't believe that people sitting in the various offices around appreciate the practical implications of some of this stuff. And frankly, as Evelyn saying, the fact that that connection reform has basically shut down all potential projects for community use in the north of Scotland is a disgrace. So I think we do need to find a way to try and make our voices heard, because unless somebody thinks this is a good idea, I certainly don't. In terms of what we can actually do, OREF does respond to consultations whenever we see them, and we try and flag those in the newsletter. So if you do see them and want to muscle up about things, that'd be really good. Even if there is anything that's actually live that people can contribute to, or write letters of support for you guys, that's something that might be of assistance, and certainly battering away at our MPs and MSPs, and also really a turn to Robert at the back in terms of the role of the SNP. Whichever way the next election goes, is likely to have a strong SNP government in one form or another. And getting this onto the agenda of the energy minister, the future energy minister, would be really, really useful, because I genuinely don't believe half of this lot has registered in the Central Belt.
Yeah, I have. I was actually in Scotland at a grid conference when it was announced that the transmission impact assessment level in England and Wales was increasing to 5 megawatts. And I said, well, what about Scotland? Because you're in Scotland and it's currently 50 kilowatts for most of the Isles, or 200 kilowatts on the Scottish mainland. So it is something that I raise every single time I'm speaking to somebody in Ofgem or NESO. And in terms of any active consultations, there's currently an end-to-end review that Ofgem are doing. I think the closing deadline's the 27th of February. And it just mentions it once that they're wanting to do this. So I think the consultation question is like, do you agree that we should do this? And I would say yes, we should. But again, that's on a very small scale of that sort of 3.68 kilowatts. So it's kind of making it easier for people to install smaller generation, rather than them not being able to install it at all, if that makes sense.
Thanks, Neil. You're okay. Well, yeah, to wrap up, yeah, I think it's a good what Neil said. Thank you. It's a good ending message. Not to say that OREF maybe can be the avenue to advocate, no, like to bring the case that you made, responding to all the consultation, and to NESO, Ofgem, and whoever can listen and do something to to change the situation. So if there are no further questions, join me in thanking Martin for this great talk and discussion, and thank you all for coming and being so active in the discussion.
Thank you.